Agar gel immunodiffusion. A plate is prepared with an agar gel into which antigen and antibodies can diffuse. Wells are punched into the agar gel and the antigen and antibody are placed into these wells. Sample being placed into a well on a gel that has been poured on a glass slide. As the antigen and antibodies diffuse toward one another in the gel, they set up concentration gradient and begin to combine. In the region close to the antibody well, the small number of antigen present bind multiple antibody. The actual number of depending on the antigen size and the number of epitope, forming small complex that remain soluble in the region close to the antigen well. The small number of the antibody present bind to antigen, forming small in the region close to the antibody well. The small number of antigen present bind multiple antibody. The actual number depending on the antigen size and number of epitope, forming small complex that remain soluble. The region close to the antigen well, the small number of antibody present bind to antigens, forming small complex that remain soluble. Extensive cross-linking of antigen and antibody can occur, forming large complexes that precipitate in the gel. The precipitate that forms is visible as single white line, precipitating line in the gel, showed in dark gray in this single precipitating line in the gel. Multiple precipitate line if the antibody well has more than one antibody, which each antibody react with different antigen in the antibody well, then there will usually multiple precipitating line. Each antigen antibody reaction produce a separate precipitating line, with the caveat that the line could overlap if the concentration were just right. The multiple lines form because each antigen antibody reaction is independent, that is, different molecular reactant combined to form different product. Line and antigen antibody identify. A modification of the technique place multiple wells at angle to one another. If different sources of antibody are placed in two wells with third well containing an antigen, it's possible to determine not only whether the antibody are present but whether they recognize the identical antigen. We make a modification by placing multiple wells at angles to differentiate between different antigens. Lines and antigen antibody defined. Lines of any identity top left. If the two antibodies do recognize the same antigen, a single precipitating line form, creating continuous between the two wells of antibody. Lines of non-identity. If the two antibodies recognize different antigen in the antigen well, then two precipitating lines form and cross one another. Lines of partial identity. Bottom. A line of identity forms for the reaction in common between two wells. A line of non-identity also forms next to the well with the extra antibody overlaps the line of identity. The resulting pattern appears as a line of identity with a spur is called a line of partial identity. Lines of identity on a slide. lines of partial identity and non-identity, multiple antibody system, antigen antibody system combination between two pills, Cabrine arthritis, encephalitis virus, Agar gel, Cabrine arthritis, encephalitis virus antigen is placed in the center, and the outer will contain either control serum known to contain antibody to CAEV. Clinical sample being tested. In this test, there is one positive sample indicated by the line of identity between it and the adjacent control wells. Agar gel for antibodies to fungal agents. This is commercially available kit for detection of presence of antibody to different fungal agent. The test on the left, coccidioides immitis,